without further ado, I'll introduce probably one of the most well-known people in the room, Alan Leidner.
Thank you. Thanks to NYU for putting this together. I think it's a really great and important event. I'd also like to thank the Open Geospatial Consortium, which really brought us all together to start this process about 2.5, 3 years ago. And I'd like to thank also the Fund for the City of New York, which I'm no longer part of, but was back then, which provided a lot of funding for the underground infrastructure project that we're still engaging in which you are, Deborah, extending through this meeting. And let me see how to work this. Okay. You'd think that with a couple of billions of dollars of savings that Wendy's examples demonstrated, that there would be a no-brainer about funding underground infrastructure data integration and improvements in underground infrastructure quality. It has not been the case. It's largely a matter of politics and of political will to make it happen. And part of what I've been trying to do, part of my job has been to show the cost-benefit reasons why you would need it in a form that everyone could understand and everyone could apply. So really what I went for was to scale the potential benefits as opposed to a very intensive analytical approach that would get it down to the penny. So this is going to be a little bit of a wild ride. You're probably not going to get all of it, but stick with me, and there's always questions afterwards. So let's go, just an overview of what we're talking about in terms of underground infrastructure. It's all those pipes and whatever under the street, but it's also the underground environment, which is from the pavement level down to the different soils, to the water table, to the hydro elements that are underground as well. And those are key to the longevity of the pipes and the underground infrastructure. So these are two good images that show our area of concern. Okay, the objective here, develop the benefits analysis. Really simple, because we were trying to come up with one number. I'll give you the number, 4.7%. Okay, that's really what we tried to build. I tried to build this whole analysis around, was one number that everyone could use. Find the rigorous studies able to cross the myriad of use cases and put cities and local governments around the world and across the United States into a position to plug and play with this analysis. Okay, so what do we mean by underground infrastructure? 4 major elements. One are the very big capital projects that you all walking down the street would know about, things like the valve tunnel at Van Cortlandt Park, or the wastewater treatment plant in North River. These are both in New York City. Both are probably multi-billion-dollar projects. They connect into all the underground infrastructure. And even if they show their heads above the street surface, we consider these to be underground infrastructure elements that we count within the context of our cost-benefit analysis. The other is, and you know this a lot better, is all the drilling that goes on in the street when they want to make a repair or where there's an emergency or where they have to lay new pipe because old pipe is aged out or starting to break. So this, you see, there are 240,000 excavations in New York City on an annual basis, which is about 30 to 40 per mile per year. So constantly accessing the underground with all the potential for accidents and mistakes. Another big element here is that every building that you see in the city has a foundation and has a basement. All those elements are in direct touch with the underground soils and also connected in with the underground network. So we consider everything below the first floor of every building to be part of the underground environment. This really sort of expands how we think about this. And we also think about it as all those basements and all those utilities in the basement after the building has been constructed. This is all in the underground environment. So we count it. Okay, so what does this mean in terms of gross money? Just taking some figures just to get a scale for how much money is spent annually in underground infrastructure, taking some figures from the General Building Construction, that's an online data source, from the Department of Environmental Protection budget, from the Department of Transportation, because we count street surface, from Con Edison, from the MTA, leaving out a bunch that we just didn't include because, you know, once we started to scale up to about $10 billion, sort of the rest was irrelevant. It could easily have gone to $15 billion or $20 billion. But when you start to work that number through, you find out that in New York City, this $10 billion translates to about 1 million people per $1 billion spent, and to about $1,000 per person per year for infrastructure that is spent, just to scale this, because then these become metrics that can be used elsewhere. Okay, so during the course of the Open Geospatial Consortium studies, we came up with a bunch of major use cases: routine excavations, major excavation, infrastructure operations and maintenance, emergency response, disaster preparedness, smart cities opportunities. And many of these had many sub-areas. I can tell you that to try to parse out all the different use cases and sub-use cases and work processes and create a cost-benefit analysis from that is almost virtually impossible. And then to do it for 7 different types of utilities and for the circumstances in each individual city, it's just overwhelming. So the goal became, how do we create a simpler way of looking at this? So the way was to break it down into 5 different categories where we could find studies that would allow us to aggregate savings percentages. And they broke down to improved data accuracy, completeness, and timeliness as one, channel, improved data interoperability and accessibility, and this is what the Open Geospatial Consortium Interoperability Project addressed, and infrastructure extended life. These are the items that we really felt we had pretty strong and reasonable metrics to deal with. Then we had 2 supplemental categories: improved disaster preparedness, response and recovery, and implementation of innovative smart services and technologies. I'm going to go through each one of these, and you'll see where we got numbers from and where those numbers lead. Okay, so first, we had guiding studies. Those were critical. We found, really fortunately, important studies that gave us numbers we could be confident of. So the U.S. Federal Highway Administration, Purdue University, came out with cost savings on highway projects using SUE, or Subsurface Utility Engineering. They discerned that if you had good data about underground infrastructure, that you could make your highway projects cheaper, less expensive. And the percentage and they had 71 roadway projects. This was a very rigorous study. I believe it's a couple of 100 pages, so go take a shot at it if you want. Their metric that they came out with was a savings with better data of 1.9%. So keep that number in mind. Okay, another guiding study was cost analysis of inadequate data interoperability in U.S. capital facilities industry. We got so lucky that we found these studies by NIST, National Institute of Standards and Technology, a reliable organization, and they did 105 structured interviews with 70 companies. So this was very rigorous. And what they came out with was, when you have a major construction project, by having all the data that goes into that project be interoperable, you have a 1.8% savings coming from that for each project. Now, that's a lowball figure, but it's a number we can use. They add up. By the way, this is just some of the other sources of data for more focused kinds of use cases and projects, but I won't go into that detail now. I want to get through with this, which is the third leg of our cost-benefit analysis here, is another category, cross-cutting category of, if you've got all the data from example 1 and example 2, and it's high-quality data, and it's interoperable data, and you can do superior analytics on that, you can put it into an asset management package, and just go to town on it to analyze the best way of managing your networks. There are studies. They don't give a clear-cut figure. I have Bob Mankiewicz here from Bentley, who I don't know if you've confirmed my estimation, but I'm saying you can extend the life. You can extend the life by 1 year in a 100-year life cycle for a particular infrastructure. And can you say, yes, that's a reasonable number? Excellent. Okay. So, and I won't give you all the reasons why, and we'll go here and we'll just work out what that comes to. It comes to 4.7% savings for the entire realm of infrastructure spending, both for capital projects and for maintenance and operations. So if you take a generic $1 billion and you multiply 4.7%, you get a $47 million benefit per billion expended. In New York City, 9.6 billion number we had from an earlier slide, that comes to $450 million in annual benefits using conservative numbers based on rigorous studies. What that means per person is about $47 in savings using underground infrastructure, improved data, $47 per person. So you can multiply that by your population or by the size of your city's capital budget and actually come up with a number you might have a chance of defending in front of your Office of Management Budget. Just very quickly, I want to bring up two additional added cases that just add window dressing or dressing to the three numbers that have been presented to you. One is that FEMA came out with a study about the benefits of mitigation for disaster response and preparedness. And they came out for every dollar spent on mitigation, you get $6 back. We consider improved data to be an element of project mitigation or of disaster mitigation. And so what you could basically say is every penny you spend on improving the data, underground infrastructure data, is a mitigation expense that actually pays you back $6. This is sort of like on another page of your analysis. And just an example of this is because we did not have good analytics on the East 14th Street substation, when that went bluey, and Wendy showed it to you, basically speaking, NYU Medical Center also flooded. The bottom line is New York City lost billions of dollars because we did not do the proper analytics, because we did not have the proper data to analyze the effect of a storm surge on the city. And the other and final point I will make here is that there's a whole element now looking forward of smart cities. And this is from a study called Smart Cities and Cost Savings by a series of private consulting groups. And they basically came out with that the future of smart cities largely resides in smart infrastructure, smart mobility, and so forth. That comes to, for a per mega city, which New York City is a mega city, of $45.7 billion per year in the future as all these technologies get developed. So that's an additional, icing on the cake for a cost-benefit analysis. And I think that's it. Thank you.
So one question that came in for Alan is, what do you think is really the next step?
Well, I think it's going forward with OGC and with conferences like this to publicize it, to develop better science, better cost-benefit analysis, and basically to have pilot projects that demonstrate the benefits of bringing all the data together and getting the data right. So what we're doing here is right on the line, and then it's to put political pressure on folks and to get some publicity for this kind of stuff. Without publicity, we're not going to succeed.
So you're saying we should all call our local city council, congressman, all of this?
We're doing that right now.
Okay.
We really are. We've become, Gizmo, which is our organization, has now officially become political. We are talking to borough presidents, and we are talking to council people, and we will make this a political issue.
Hey, Alan. So as far as the data collection is concerned, historically, the last time this level of data was collected, at least from a soil perspective, was the New Deal in the 1930s. So I guess my statement is, are any of the Green New Deal rhetoric, are there incentives that are aligned here where you can align your work with some of the federal upcoming Green New Deal rhetoric?
Well, firstly, we see the federal government absolutely essential player in this. We can't do this without federal support and federal technology and federal smarts. But what we also know is that New York City has a lot of underground data. It's not all high quality, but there's a lot of different places that have soils data. There are federal agencies that have some of that data as well. What has not happened is that data has not been identified and brought together and integrated to create a baseline from which we then improve things in the future. So that's part of our effort, is to get that darn data together and to start making sense of it, create standards for future data, and to keep building on it. So that's, again, as much a matter of political will as anything.
We're going to take one more quick question in the back.
240,000, yeah. Separate events, I know. It's a mind-blowing number, but it's confirmed because a presenter from Flanders will give you the same number, and our friends in British Ordnance Survey say the same for London. So that's really the way it is.
All right. Thank you very much. Alan will be around all day, so